Lesson 20: Decision-Making in AI, the Black Box Problem. When we talk about AI systems, we often hear that they are capable of making decisions, but how are those decisions actually made? Can we understand how an AI system arrives at a certain conclusion, and can we explain it to others? Those questions bring us to one of the most complex issues in AI, the black box problem. The term black box refers to a situation in which we see the input, for example, customer data, and the output, for example, loan approval, but have no idea what happened inside the system that led to that decision. We know what we went in and what came out, but not what happened in between. This is a major challenge in advanced AI models. As AI systems become more complex with thousands or even millions of internal variables, it becomes harder to understand why they chose a particular answer. For example, if a system recommends a medical treatment, decide whether to approve credit or classify as an image, it is important to understand why it did so. If we don't know the logic behind the decision, it becomes difficult to trust it, verify its fairness, or correct it when needed. However, not all AI systems are black boxes. Simpler models based on clear rules or decision trees can be fully explained. For example, if income is above 7,000 NIS, credit history is good, the client is over 22 years old, and the loan is below 100,000 NIS, the loan is approved. Those models are easier to monitor and explain. But in more advanced models, such as those using language processing, image recognition, or complex economic forecasting, it becomes almost impossible to identify which factors influence on the decision. It's like trying to understand how a human brain reaches a conclusion, but instead of a brain, we have a network of mathematical computations. Despite the challenge, there are efforts to develop tools that can partially explain AI decisions. For example, we may be able to identify which pieces of data had the greatest influence or understand which patterns were detected. Those tools offer general indicators, but not a complete or precise explanation. Take a simple case. System classifies an image of a dog as a wolf. Upon investigation, it turns out that the model was influenced primarily by the snowy background, because previous wolf images its source always included snow. The model learns from context, but learn the one thing: the issues is not only about understanding, it's also about responsibility. If the system makes an incorrect decision, who is accountable? The programmer, the organization that implemented the system, or the end user? Without a clear explanation, it's hard to assign responsibility or correct the process. In conclusion, as we integrate more AI systems into decision-making in the workplace, it becomes increasingly important to recognize the limitation of those models and the nature of the black box. While we may not always be able to decode a model's inner logic, we can demand partial transparency and maintain human oversight.